Randomized experiments are generally built on four principles. Controlling the effects of confounding variables on the response so that the subjects receive identical treatments except for the explanatory variable. Randomizing subjects between treatments and control groups. Replicating the number of subjects between groups to reduce chance variation in the results. And blocking for known variables that might influence the results. Okay, so let's go through each of these one more time, one at a time. Controlling. Researchers assign treatments to cases and they do their best to control for any other differences in the groups. What that means is they basically want everything between the control group and the treatment group to be identical as much as possible, except for the treatment itself. For example, when patients take a drug in pill form, some patients take the pill with a sip of water, while others may take an entire glass of water. So if you want to control for water consumption, a doctor may ask all patients to drink a 12-ounce glass of water with the pill. Now, randomizing. Researchers randomize patients in the treatment and control group to account for variables that cannot be controlled. So recall from past lessons, there are confounding variables out there that we may or may not be aware of. If we randomize patients, then all those different confounding variables should be more or less equal for each group. That way, if there is a difference between your treatment group and the control group, it's because of the treatment and not because of some other hidden variable. So, for example, some patients may be more susceptible to a disease than others due to their dietary habits. Randomizing patients in the treatment control group helps even out those differences and also prevents accidental bias from entering the study. Replicating. Essentially, replicating means sample size. So the more cases researchers observe, the more accurately they can estimate the effect of an explanatory variable in the response. That is, the larger the sample, the more accurate your study tends to be. So in a single study, we replicate by collecting a sufficiently large sample. Additionally, a group of scientists may replicate an entire study to verify an earlier finding. And finally, blocking. Researchers sometimes know or suspect that variables other than the treatment group may be influencing the result. So under these circumstances, they may first kind of group individuals based on those variables into blocks, and then randomize cases within each block for treatment control groups. So for instance, if you're looking at effect on a drug on heart attacks, you might first split patients into low-risk and high-risk blocks. And then your low-risk block, you break into treatment control. Your high-risk block, you then randomly choose between treatment and control. All right, take some examples. An article in the Washington Post reported that, according to 2 large studies, obese people are significantly less likely to die prematurely if they undergo stomach surgery to lose weight. But people choose whether they have stomach surgery, so explain why this fact makes any conclusions about cause and effect untrustworthy. Well, one thing, if people are choosing to take the stomach surgery, then generally those who choose to have it are those that want to become healthier. So people were not randomly chosen to participate, so confounding variables may explain the results. In this case, people choosing to have stomach surgery are likely to be more concerned about their health than those who did not, and are likely to making changes and other changes as well. So the overall change in lifestyle, and not necessarily the surgery itself, could explain the results. All right. To study the effect of neighborhood on academic performance, 1,000 families were given federal housing vouchers to move to out of the low-income neighborhoods. No improvement in the academic performance of the children and the families was found 1 year after the move. So explain clearly why this lack of improvements in academic performance after 1 year does not necessarily mean that neighborhood does not affect academic performance. Okay. So One possible reason is that even though families were given federal housing vouchers to move out of low-income neighborhoods, they did not necessarily move into better neighborhoods. So the new neighborhoods themselves may not have been good enough to make any real difference. All right, another one. The progress of a type of cancer differs in women and men. A clinical experiment to compare 4 therapies for the cancer therefore treats sex as a blocking variable. So suppose you have 500 male and 300 female patients who are willing to serve as subjects. So let's outline a block design for this. So first off, we have our 800 patients. Now, if you want to do a block, this is the non-random part, is we first separate them to the 500 males and 300 females. Now, the random assignment comes into, for each of those different groups, you have treatment and control. So we have treatment and control for the males, random assignment, treatment and control for the females. So what are the advantages of block design over a completely randomized design using these 800 subjects? Well, one of the reasons we have block design is that it provides more accurate results than the completely randomized design due to grouping. And there's some flexibility there in that we can have any number of treatments in blocks.